Okay, so in this week's episode, we're going to be finding velocity from uniform acceleration, and we're going to find out how far that trolley did travel in the end. So in case you haven't seen the last episode, I'll just put this in a teeny bit of context. We had a look at acceleration, and basically what the acceleration for a trolley was after a certain point, using the initial velocity, how fast it was going at the beginning, which was from rest, so it's 0, to a finish line, how fast it was going at the end. But I recommend seeing that video as a prerequisite to this video. You don't have to, but it sure does put the whole trolley thing into a bit of context in case you're interested in getting some context around this. So, we had a trolley last week, and its initial velocity was 0 meters per second, because obviously it was at rest when it started. And its final velocity, when we had a finish line down here, was 1.8 meters per second. We then deduced, using a formula, the acceleration must have been 0.6 meters per second per second. The acceleration, again, just to recap, is basically the velocity, the change in velocity per unit of time. So it was going 0.6 meters per second as an increase every second, if that makes sense. Again, I'd recommend seeing my dedicated acceleration video. Just search FunPhysicsAssistant and acceleration. Today we're going to work out what distance is. Distance is basically shown as s, so how far that trolley travelled, and we're also going to calculate the average velocity of that trolley. So in some of my earlier videos, I use this to calculate the average velocity of a trolley, displacement over time. In this particular one, I'll just fix this up here to a 2. Average velocity is basically the final velocity plus the initial velocity divided by 2. And this is just averaging, really. It's just mathematical averaging, because essentially when you have two numbers that you need to average, you always add them together and then you divide by the number of numbers. So if it was 3 and 6, you divide by 2 after adding them, and you get 4.5 in the end. It's the exact same thing here. We're just taking how fast the trolley was at the finish line, how fast it was at the beginning, and then dividing by 2 to get the average journey in between. So I guess that really does make a lot of sense what we're doing here. So without further ado, let's substitute in our values from our little list of values and work out basically the average velocity of the trolley using this formula. So the velocity final at the finish line was 1.8 meters per second, and again, this is in meters per second, so we don't need to convert it. If it was in kilometers per second, then we'd need to change it into meters per second, but it's already in SI units. I will be doing a video about how to convert later on, but for now, don't worry about it. So if it's in meters per second, just write it in. And the initial velocity was from rest, so 0. And then we divide it by 2. I'd like to simplify this down, so I'd write 1.8 over 2, because essentially at 0 doesn't really mean a lot. And then we get, as an end result, 0.9 meters per second. And of course, because this is velocity, it requires direction, because it's a vector quantity. I also did a video on that that's worth looking if you're interested. But we get 0.9 meters per second as our average velocity. So that's the average velocity of how fast that was going down the slope. Of course, it would be slower at the beginning as it's gaining speed, and faster at the end as it's just playing through the finish line. But essentially, that's how we deduce the average of that trolley's trip. So now on to speed. And speed is reasonably easy. However, you just got to remember this formula, and it might take a little while. But essentially, it is the initial velocity and time plus half of the acceleration, and we just put these arrows above it because they're vector quantities. It's just a neat little thing that we do in physics as housekeeping. So, as I said, half the acceleration and then time squared. So that's our formula. And to work it out in this trolley context, of course it always equals s, which is the distance, we'd have an initial velocity of 0 meters per second. Again, that's because it's from rest. The time was how long it took to roll down the hill, and in the previous video, and I mentioned it at the beginning of this one, it took 3 seconds. The acceleration from the last video we worked out was 0.6 meters per second. And as I said before, the time is just free, so that's all sorted. So we got all our values that we need to be able to calculate, which is great. Just remember that basically here in this example, it's always good to draw a diagram as well, just to be able to get context of the problem. You don't have to, but if it helps you understand it more, you're actually able to label it, especially when you're just starting out with physics, to be able to be aware of the different components and where they roughly sit, just to make sure you've got everything. And because they're all in SI units, meters per second, not kilometers per second, seconds, and meters per second, they're all in the same sort of range, so therefore we're all good to go ahead and plug them into our formula and find out how far that trolley travelled. Whoops, so we'll have the distance down there, but let's calculate. So distance is obviously going to be equal to 0 multiplied by the time of free, plus half of the acceleration, which is 0.6, times t squared, so free squared. So now that we've got that, we're able to simplify that because free times 0 is 0, so we're just going to immediately forget about the original part, and we're going to go into this. So our distance is essentially half of 0.6 times by 9. Again, what I've just done is I've gone free squared equals 9, so we're able to get that. And then you just calculate basically what that means. And then you should be able to reach an answer. And from that, it's basically half of 0.6. So we get 0.3 and then 0.3 times 9. So 3 times 9 is 27, of course. So then what we get from this is 2.7. So therefore, our overall answer is 2.7. So it's just about doing the maths there. Again, half of 0.6 is 0.3, times 9 is 2.7, because 9 times 3 is 27, then we just plug in the decimal. Just standard arithmetic stuff, really. Nice and basic. And then we get 2.7 meters as being how far the trolley travelled. So that's our distance. Distance is represented using s. So again, just a recap of the formula, it's the initial velocity, time, plus half of the acceleration time squared. And that's how we're able to get the distance that the trolley travelled. So 2.7 meters within 3 seconds. And of course, it's greater than the final velocity of 1.8 because the object was accelerating. But that's just a brief heads up on basically how to calculate distance. I hope you found this useful, and thank you very much for watching.